So I've had some students ask for a review on redox reactions. So the first thing I want you to remember about redox reactions is when we're talking redox, what we're talking about is oil rig. And what this stands for is that oxidation is the loss of either electrons or hydrogens, while reduction is the gain of electrons or hydrogens. And if you're having trouble in your mind recalling why that is, remember that when we acquire electrons, we're becoming more negative in terms of charge. And so as a result, the charge of that molecule is being reduced. Okay? So this is the general idea of what you need to understand to classify things as being reduced or oxidized. And remember, when we're saying something's reduced or we're saying something is oxidized, we're always talking about the reactants of a particular process. So let's go ahead and take a quick look at how we would determine if something is being reduced or oxidized given a particular equation. Right, so we'll go ahead and just use something we've seen many, many times before. Let's use the equation for respiration. All right, so we have sugar in the form of glucose plus molecular oxygen yields water, carbon dioxide, and ATP. So one of these two things is going to be reduced and the other is going to be oxidized. So there are several steps that I have established that you should follow when you're attempting to determine what's being oxidized versus what's being reduced. Step one, find a particular element in only one reactant and only one product that's unique. So only those two things have it, one reactant and one product. And remember, it cannot be hydrogen. So here in this example, the one that we can find that's unique is carbon. Only one product and only one reactant contain carbon. Glucose contains carbon, carbon dioxide contains carbon. So that's step one, identify that unique atom or element. Step two, draw your arrows. That is, one reactant is going to become one product and the other reactant will become the other product. Since we've established that carbon is unique for these two molecules, the only place that this carbon could have originated from is this molecule here. So glucose becomes carbon dioxide as we proceed through this reaction. Okay. Oxygen, on the other hand, becomes water as we proceed through this reaction. So, step one, identify the unique element or atom. Step two, draw your arrows. For the third step in my process, what you're going to want to do is just write down each element in a simplified way. All you need to write down here underneath each element is what atoms make up that element. And you don't even need the numbers. You just simply need to write for glucose C, H, O. For oxygen, you just write O. For water, H, O. And for carbon dioxide, C, O. So now that we've identified that, let's go ahead and now figure out what's being reduced and what's being oxidized. So, glucose, as it goes to carbon dioxide, is it gaining or losing hydrogens? Well, we can see we start with C's, H's, and O's, but then we just go to C's and O's. So it lost hydrogen, and remember, oxidation is loss, so glucose is oxidized to carbon dioxide. Up here, oxygen, as it becomes water, gains hydrogen, so oxygen is reduced to water. So, you've drawn your arrows after you've identified a unique atom or element. You've written out what composes each of these, and now we've determined what's being oxidized and what's being reduced. There are two final questions that we can ask ourselves. The first is, which of these is the oxidizing agent? Okay? And which is the reducing agent? And the next question we can ask is, which of these is an electron donor and which one is an electron acceptor? So let's answer the agent question first. Now remember, just like a travel agent doesn't actually go on a flight with you, they simply book your flight. When we're using the terms oxidizing and reducing agents, we're not talking about what's happening to that molecule, we're talking about what that molecule is doing to the other molecule in the reaction. So let's look at glucose. Glucose adds hydrogens to oxygen to convert oxygen to water. And what that means is by adding those hydrogens to that oxygen, glucose is reducing that oxygen. So glucose is called the reducing agent. Oxygen, on the other hand, is accepting those hydrogens or electrons from glucose. And so by accepting or taking those hydrogens from glucose, it's oxidizing glucose. So we call oxygen the oxidizing agent. And the final classification is whether one of these is an electron donor or an electron acceptor. And hopefully you can already kind of see what's happening here. Glucose is giving electrons to oxygen as we proceed through this, and anytime you give money or give blood, you're considered a donor. So in this case, glucose is classified as the electron donor. Oxygen, on the other hand, is accepting those electrons, becoming water, and so it would be an example of the electron acceptor. So if you can remember the steps I laid out to set up this equation to determine what's being oxidized and reduced, there's a fundamentally easy way you can also remember how to classify things as oxidizing agents, reducing agents, donors, and acceptors when it comes to electrons. The reducing agent and the electron donor, so the reducing agent and the electron donor, are always the substance that is oxidized. The oxidizing agent and the acceptor is always going to be the substance that is reduced. Okay? So this is essentially how you would handle a redox reaction from start to finish.